works. This part works with cycle as well, but so our pipeline is actually built on top of a loops render. But again, this is the projected square. Now, when projected background is matching, even though it was completely wavy and all that, and to prove that, I'm going to take the camera, we're going to align the camera with the horizontals, and you can see that even though the original panorama was wavy, we now have a very artistic-friendly coordinate space to work with. You just have X and Y, and everything's going to work. Okay. Just some examples. Well, just you can see there on the top left corner actually the X and Y axis of the coordinate of the sphere, where the panorama is created from. So senior reconstruction. Again, you're not doing that automatically, but we're facilitating to the depth reconstruction through inside Blender. So we have these. Let me go to since we know that a lot of the main features, at least for us originally, we wanted to build the whole set from the ground up. We had a lot of key features in the ground that we could easily recognize as geometric shapes. So, for example, these 3 points here, they can define a circle. So I go here, I created the 3 points, select them, and go here, draw circle, and boom. Oh, I should be using, and boom, it's here, it's matching. Convert to circle, let's edit. Now we see a problem. I'm trying to extrude the column, but cycles, that allows me to see the panorama as a background, does not allow me to see the mesh while I'm editing the mesh. It needs to keep flushing on when I go back to object mode. So you can see here on the bottom on the bottom screen that I can kind of eyeball it, but it's not nice. I need to go out and on. So we build a very nice script to project the panorama on the edit mode. So here we're editing, and you can pretty much see the panorama. You can see rotate, you can look all around. So let's say I want to have one of these rectangles here. I'm going to ask it because it breaks sometimes, because this is a bit hacky. It's beautiful. So 3 points should be enough to define a square. 2 can define a square. Okay, so that's one part. 2 can define it doesn't matter, polygon. So like I have a half triangle here. But the idea here, so here's that half triangle we had there. The idea here is that you can pinpoint your main features. For example, the whole scene outline, the whole polygon that defines a floor that can just extrude the ceiling. I'm going to open here as an example the file I was doing like 2 days ago. Meaning it's very easy to. So this file, forget about the spheres, they're hiding. This file here, that's all the geometry I'm reconstructing. And it was all done. It's relatively quickly. Of course, it's not as fast as if you could just scan it, right? Scan the 3D mesh. But you can see that it's really nice to work in the 3D view. And that, for example, the balcony, this desk here, it's actually defined here. We define 3 points. Here. Yeah. Oh, I deleted points from the desk. But you can see here all the points I used to reconstruct this particular scene. The column, the main outline of the floor. I think you see here the points. It's very straightforward. That's more curious. It's actually a GLS filter running on the 3D view. So it's really nice. It's a non-intrusive system, and it's really portable to the other 3D applications. And it's really nice how then is that flexible. So let's speed up a little bit. These are examples of 2 depths of 2 different scenes. On top is that first level I was showing. On the bottom is this hall of this museum. And let's quickly talk about the rendering. So as said, we're using the loops render. And this is what you're going to see when you press render. However, the different mesh, they have different types according to their role in the rendering process. So all the blue mesh here as what we call synthetic elements. So the spheres, the carpet, the little doll. The support mesh and the environment mesh are the ones we reconstructed. And the supports are the ones that we know are going to receive shadow. You could just say that everyone might receive shadow, but that might be too slow for the rendering. So we are clearly differentiating what receives shadow and what is only there for the reflection line. So that's the bit environment. So here you can see that even though internally there are different objects, once you render them out, you shouldn't really be able to distinguish between them. That's the idea, at least. I'm going to jump between these, but that's an explanation of how is the shadow calculation and the reflection. Again, we have papers that can go over the technical details. Just one thing that should mention is that this only works. So here there's two things that we're implementing. One is this Panorama solution with the depth, but the other is this long-pass render solution that I didn't really explain. It was Aldo's master thesis. And then this idea is that before you add synthetic elements, you analyze only the environment, and you know only from the environment what's the light contribution that this phase is going to receive in the end, without any synthetic object. So this way you can calculate the inverse lighting contribution, and then if you have an object casting shadow to this, it simply is going to go naturally to the render calculation. That's more fun. Some render results. So as you see, the shadow they have slightly different directions, and that's the idea. So we're no longer relying only on a directional only map. This is another result. This is actually got to show that this works not only for our panoramas. I contacted some session from the blendedskies.com. They are producing some panoramas and selling this as a service. And so I got this panorama on Wednesday, I think, and just did the reconstruction while enjoyed the conference. And it's I'm really happy with the result. This is a dirty render, so it was quite quick. So you can see some artifacts, but it merges really well. You see, for example, the balcony here and the reflection on the sphere. No, it's exactly placed where it should be, where we expect it to be. Some quick conclusions. That when you actually have the depth map, you no longer have this directional light that's perfect for outside environments, but for inside, we actually need a point cloud of light points. So actually, we want your light to be point light for your whole scene, and that's what we're doing. This solution also has no impact on performance, based on the Lux render pipeline. Some people might say that's a disadvantage, but one pass render solution is really handy for quick visualizations, for architect visualization, for example. You don't want to deal with compositing, all the whole hack shader idea of cycling maybe. We believe since Lux render is pretty much built on top of BRDF, it should be extendable. This technique could be implemented in different engines such as cycles. And yeah, it's some quick issue things. Something nice we can also have we call environment deformation. So once we reconstruct the environment mesh, we can set, we're storing the position from the original panorama mesh in the couch, for example, and we deform the mesh in Blender. Then we can have these balls nicely deforming the couch. This is no different from camera mapping, but they are camera mapping with an HDR image. It's a bit more fancy on that thing. Another is camera traveling. Even though we capture the scene from the tripod and we render from the same position, you can still move a little bit if the mapping is good. So you can see here, especially the wall that is occluded on the left render. On the right render, you can actually see it. So it allows for panning, zooming, and traveling. That's, I think, pretty much what a filmmaker wants in terms of review. And last but not least, since we can actually go all the way back to the panorama render, we can actually get any kind of anamorphic lens from it. So in this case, we're rendering fish eyes out of the rendered panorama. So people working domes and this kind of projections. It's a really nice workflow to work with. It's also nice feat. Just quickly, I'd like to thank Jama Lucio